Today we discuss about the 4 questions from the section Inverse Trigonometric Functions that have appeared in the Joint Entrance Examination Main in the January 2024 session. The first question is, this question has appeared in the JEE Main exam held on 27th January 2024 in the second shift. The given question is, considering only principal values of inverse trigonometric functions, you have to consider only the principal values of inverse trigonometric functions, the number of positive real values of x satisfying tan inverse x plus tan inverse 2x is equal to pi by 4 is. We have to find the number of positive real values of x satisfying this trigonometric equation from the given 4 options. Let's now discuss the solution of the problem in detail. To find the number of positive real solutions of this given equation, tan inverse x plus tan inverse 2x is equal to pi by 4. First of all, you have to take the given hypothesis seriously. That is, you have to consider only the principal values of the inverse trigonometric functions, not the general values. Agreed. Now, we have to find the number of positive real solutions of this inverse trigonometric equation. Right. So write the directive, take the tan on both sides and write the formulae. So we apply tan on both sides, apply tan of a plus b formula on the left hand side. Then you will get tan of tan inverse x plus tan of tan inverse 2x by 1 minus tan of tan inverse x multiplied by tan of tan inverse 2x is equal to 1. You can apply directly also. And you will get x plus 2x by 1 minus x into 2x, that is 1 minus 2x square in the denominator. Now simplifying, we will get a quadratic equation 2x square plus 3x minus 1 is equal to 0 is a quadratic in x, and apply the formula x is equal to minus b plus or minus under the square root of b square minus 4ac by 2a, and you will get the roots as minus 3 plus or minus root 17 by 4. In this, if you take minus 3 plus root 17 by 4, that is positive. Why? Root 17 is little more than 4 and 4 minus 3 is positive. So you will see x is equal to minus 3 plus root 17 by 4 is greater than 0, and x is equal to minus 3 minus root 17 by 4, both are minus, it is negative. And we have to consider only the positive real values of x satisfying this equation, that is the positive real solutions of this equation, and you have to consider only the principal values. So because we are considering only the principal values, so the number of solutions is only 1. So the number of positive real values of x satisfying the equation is 1 because we are considering only the principal values. Agreed. So our answer 1 appears against option 4. Therefore, the answer to this question is option 4. So that is the detailed discussion of the problem, and I am sure that you have understood the solution of this problem, and it is definitely an easy problem. Let's move to the next question. This question has appeared in the JEE Main exam held on 29th January 2024 in the second shift. The given question is, let x is equal to m by n, where m comma n are co-prime natural numbers, m and n are natural numbers, and they are co-prime, means the GCD of m and n is 1. And x is given to be a solution of this trigonometric equation. Cos of 2 sine inverse x is equal to 1 by 9, and let alpha, beta, alpha greater than beta be the roots of the equation mx square plus nx minus m plus n is equal to 0. So you are given x is a solution of this trigonometric equation, and you are given alpha, beta, alpha greater than beta are the roots of, with those m and n, you have to write down this quadratic equation, and alpha, beta, alpha greater than beta are the roots of this equation. Then the point ordered pair alpha comma beta lies on the line, and you are given the equations of 4 straight lines. So you have to find out this point alpha comma beta lies on which of the given 4 lines. We will now discuss the solution of the problem in detail. Right. We are given x is equal to m by n, and m and n are natural numbers, and the GCD of m and n is 1, and it is given x is a solution of this trigonometric equation. Right. So let's now put sine inverse x is equal to theta, and thereby x will be equal to sine theta. Then x is a solution of this equation. Take this equation and take the cos, then that will be equal to cos of 2 sine inverse x, 2 theta. Cos 2 theta is 1. Right. For cos 2 theta we have written 1 minus 2 sine square theta, that is equal to 1 by 9. And solve for 2 sine square theta, that is comes out to be 8 by 9. And sine square theta, x is sine theta, sine square theta is 2x square, 2x square is equal to 8 by 9. So x square is equal to 4 by 9. Then x will be equal to 2 by 3 we take, and minus 2 by 3 we reject it. Why? X is equal to 2 by 3 because x is m and n, x is equal to m by n, where m and n are natural numbers, therefore x is positive. And you have to take such an x where it will look like m by n, where GCD of m and n is 1. Therefore, you take x is equal to 2 by 3, and 2 and 3 are relatively prime. So from this you will get m is equal to 2, n is equal to 3. Now form this quadratic equation, mx square. So with these values of m is equal to 2, n is equal to 3, form this equation, quadratic equation. Mx square plus nx minus m plus n. Substitute m is equal to 2, n is equal to 3, and simplify. You will get 2x square plus 3x plus 1 is equal to 0. For this, it's a quadratic equation. You expect 2 roots. Let them be alpha, beta, but you have to take alpha and beta like alpha greater than beta. So find the solutions. So factorize, and the solutions are x is equal to 1 and 1 by 2. Alpha and beta are the roots of this equation, and alpha greater than beta you have to consider. Therefore, x is equal to 1 is to be taken as alpha. That is, alpha is equal to 1 and beta is equal to 1 by 2, because alpha greater than beta. Right. So alpha is equal to 1 and beta is equal to 1 by 2. Thus, we get the ordered pair alpha comma beta, that is 1 comma 1 by 2. Now take this ordered pair and go on checking on which line this ordered pair lies. And on checking, you will find 1 comma 1 by 2 lies on 5x plus 8y is equal to 9. Why? 5 into x, 5 into 1 plus 8 into 1 by 2, 4. That is 5 plus 4 is 9. So 1 comma 1 by 2, that is alpha comma beta, lies on this equation, and that is given in the option 4. The answer to this question is option 4. Now let's move to the next question. This question has appeared in the joint entrance exam main held on 31st January 2024 in the first shift. The given question is for alpha, beta, gamma not equal to 0 if sine inverse alpha plus sine inverse beta plus sine inverse gamma is equal to pi, and alpha plus beta plus gamma multiplied by alpha minus gamma plus beta is equal to 3 alpha beta, then gamma equals, we are given 4 options. We are given alpha beta gamma not equal to 0 and sine inverse alpha plus sine inverse beta plus sine inverse gamma is equal to pi, and you are also given alpha plus beta plus gamma multiplied by alpha minus gamma plus beta is equal to 3 alpha beta, then required to find the value of gamma. Let's now discuss the solution of the problem in detail. Agreed. We have alpha beta gamma not equal to 0. And we are given sine inverse alpha plus sine inverse beta plus sine inverse gamma is equal to pi. Right. Let sine inverse alpha is equal to A. Similarly, sine inverse beta is equal to B. Sine inverse gamma is equal to C. And thereby, this equation will become A plus B plus C is equal to pi. And sine inverse alpha is equal to A means sine A is alpha, sine B is beta, sine C is gamma, and thereby you will get alpha by sine A, that is 1, is equal to beta by sine B is equal to gamma by sine C. So what are we observing? That means this is a sine, the sine law. So that means it is forming a triangle, alpha beta gamma not equal to 0. That is why they are given none of them not equal to 0, and thereby this forms a triangle with sides alpha, beta, gamma and angles A, B, C, and this sine law is true. So this is the one. That means the situation is in the triangle, and you have to use the properties of triangles in this if necessary. So we are given alpha plus beta plus gamma multiplied by alpha minus gamma plus beta is equal to 3 alpha beta. And this product we will write it as alpha plus beta plus gamma multiplied by alpha plus beta minus gamma. And we will apply a plus b into a minus b, that is a square minus b square, and you will get alpha plus beta whole square minus gamma square is equal to 3 alpha beta. Now write down for alpha plus beta whole square, alpha square plus 2 alpha plus beta square minus gamma square is equal to 3 alpha beta. Adjust the terms. Then you will get alpha plus alpha square plus beta square minus gamma square is equal to alpha beta. Then you will get alpha square plus beta square minus gamma square by alpha beta is equal to 1. Now multiply throughout by 1 by 2. Then you will get alpha square plus beta square minus gamma square by 2 alpha beta is equal to 1 by 2. And apply the properties of triangles. What is this? This is cos gamma. This is cos gamma. So this will imply cos gamma is equal to 1 by 2, and we want gamma. What is gamma? Gamma is sine C. So if you know cos C is 1 by 2, sine C is under the square root of 1 minus cos square of C, and that is equal to root 3 by 2. And what is sine C? It is gamma. So we want gamma. Gamma is equal to sine C is equal to root 3 by 2. This answer appears against option 3. Therefore, the answer to this question is option 3. And that is the detailed discussion of the solution of the problem. And it is also a very simple and straightforward question. Let's move to the next question. This question has appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given question is, if A is equal to sine inverse of sine of 5, and B is equal to cos inverse of cos of 5, then A square plus B square is equal to, we are given 4 options. Let's now discuss the solution of the problem in detail. And it will be easier, it will be easier if you discuss through the graphs of y is equal to sine inverse of sine x and y is equal to cos inverse of cos x. It's easier. It's easier. Of course, if you know this y is equal to sine inverse of sine x and what is this value? So it will be branch wise will be there, and remembering all of them sometimes it is difficult, but remembering this y is equal to sine inverse of sine x and y is equal to cos inverse cos x through their graphs is easy. Okay, let's look at y is equal to sine inverse of sine x. This is the one. Between pi minus pi by 2 to plus pi by 2, y is equal to x. Between pi by 2 to 3 pi by 2, y is pi minus x. This is a straight line. And when x is 3 pi by 2 to 5 pi by 2, y is x minus 2 pi. Likewise, it goes on. It goes on. So, notice that where is this 5 lies? Because we want sine inverse of sine 5. Now, you observe that 3 pi by 2 less than 5 less than 2 pi. Why? You take the value of pi and substitute. You will get 4.7 is less than 5 less than 6.2. That means it is close to 3 pi by 2 on the right hand side. So where is this pi? 5. So 5 will be 3 pi by 2 less than 2 pi. Less than 2 pi. So this is here. This is here. But that means, this will be 3 pi by 2 to 2 pi. Between that 5 will lie. And 3 pi by 2, 5 pi by 2, y is x minus 2 pi. So we have y is equal to sine inverse of sine x, that is x minus 2 pi in this interval 3 pi by 2 to 5 pi by 2. So now what is that you want? A is equal to sine inverse of sine 5. So a is equal to sine inverse of sine 5 and that is equal to 5 minus 2 pi. Agreed? So let's go to the y is equal to cos inverse of cos x. It's again like this. Between 0 to pi, y is x. Between pi to 2 pi, it is y is equal to 2 pi minus x. Between 2 pi and 3 pi, y is x minus 2 pi, and it goes on like that. So, and again, you observe that 5 lies between 3 pi by 2 to 2 pi. So, 3 pi by 2 to 2 pi. So, somewhere here. Yes. Yes. And between this, the y is 2 pi minus x. So, x is 5. So, you will have, we have y is equal to cos inverse of cos x, and that is 2 pi minus x when pi lies between x and when x lies between pi and 2 pi. And of course, 3 pi to 2 pi is and pi to 2 pi. So the same curve you will get. So b is equal to cos inverse of cos 5, that is 2 pi minus 5. So we want a square plus b square. So that is equal to 5 minus 2 pi whole square plus 2 pi minus 5 whole square. This is one and the same, 2 times of 2 pi minus 5 whole square, and 2 into 2 pi minus 5 whole square is expanded and multiply, you will get 8 pi square minus 40 pi plus 50. So let's look at our options. Our answer 8 pi square minus 40 pi plus 50 appears against option 3. The answer to this question is option 3. And that is the detailed discussion of the solution of this problem. And this is also, I can't say easy, but it is not difficult, provided you remember these graphs. Agreed. So thus we have come to the end of the discussion of the 4 questions meant for the discussion for today's video, and they are on inverse trigonometric functions. And these 4 questions have appeared in the JEE Main January 2024 session examinations. I am sure that you have understood the solutions of these 4 problems, and I wish you all the best. Thank you.